Hello, everyone. Good evening for everyone that is in the same time zone as me, and welcome to the talk Streamlining Configuration with Kotlin, Harnessing Inheritance, Variables, and more for enhanced efficiency. Of course, just as any talk, let's start with who am I? My name is Jamie Bergmans. In my regular day job, I work full-time as a software developer for .NET applications at Kenze. And in my spare time, I work for a company, as she just mentioned, Bite Me Games, where we make games. We also document the entire journey of the startup on our social media. But obviously, for those games, that is what the stock is for. So first of all, why this stock? Well, I have to start back with a little story. In the past, we initially started writing our games and using GitLab as our Git provider. We also put all our pipelines and everything in GitLab. But we ran into a few issues at first where we couldn't really run our game pipelines anymore because we needed graphical capabilities, which GitLab was unable to provide for us because we ran it via a Docker container and all that. And we were looking for a new solution. Eventually stumbled upon TeamCity after looking at a lot of alternatives, some of which were free, some of which weren't. And when opening TeamCity, we started as just clicking together a normal pipeline as anyone would, and quickly discovered that, of course, you can also do it programmatically, but there was an option for Kotlin, which, as a programmer myself and not really an infrastructure guy, sounded very interesting for me. And so diving into that a bit deeper, found a lot of information about it, of course, but also had to piece together a lot myself. And it looked very promising. So what you can expect from this talk, we are going to create a full Kotlin-based CI/CD pipeline with, first of all, a simple config. So we will just have a simple Unity build that will not do much else. Then we will be cleaning it up and putting it into multi-files, making sure everything is a little bit easier to read, and also if the application were to get bigger. We are going to be doing this on a multi-OS basis as well. So our pipeline will run both Windows, macOS, and Linux. And then lastly, we have to do every developer's favorite thing. We need to make sure that tests are running. Of course, we don't need to write them. Our job is a little easier sometimes. Is there anything else you really need to know about me? Yes, one thing. I do not like PowerPoint presentations at all. With that being said, of course, we are going to do a live demo, which is always a really good idea. But I'm sure it'll all be fine. So just to start off with, what are we starting with? As you can see here, for those, but let me actually, before we begin, ask who here, I would ask online as well, but unfortunately I cannot read the chat. Who here in the room has used TeamCity before and actually any kind of CI/CD programmable interface? That would be only a few people. Okay, so then this will be new for a lot of you. I will start very easy, and it will gradually get more and more advanced. But if you know a little bit of code, then should be fine to follow along. So as you can see here, I have got an empty project right now. It's just an empty Kotlin project with just the basic template that TeamCity provides. And we are running on one of the latest versions. I'm not exactly sure if it is the latest version, but that doesn't matter for this talk. And if we look in TeamCity as well, I will show you that it is completely empty. And there is nothing configured here for build configurations. So nothing is configured at all right now. Let's first start by adding a few basic details. So I will give a little bit of information since a lot of people haven't really used it apparently. And first of all, we need to define a way to connect with our game on the Git repository, because by default, TeamCity right now is only connected to a repository that houses the Kotlin files and configuration files, but it cannot pull in any game data yet. So to do that, we can add a VCS root, which handles all our versioning logic. And I am going to copy and paste this in because there's no use writing this from scratch. It doesn't teach you anything. It's just how to connect to our repository, which is hosted on GitLab. And then in TeamCity, you obviously always have to also reference this in your project. I'm going to say obvious a lot because I expected a little bit more people to have already worked with this before, but it's all fine. I will try and explain as much as possible. So within our project, we will always define everything we want to link. So we define our VCS root. We are going to define build types, which are ways to tell TeamCity to add a new build configuration. And I'm going to do just that right now. We are going to add a new build type. Oh, I am typing on the wrong screen. That's obviously not great. And in that build type, I am going to add a few steps. I'm going to add a step that says a Unity build. So we'll just give it a name of Unity builds. And also, if you do notice any mistakes, there's a good chance I'm testing you, but there's also a really good chance I just messed something completely up. So feel free to yell at me through the room or through the stream. Either is fine for me. Also, can't forget that every build type also needs a complete unique ID. And just as before, I'm going to paste in most of this because this is just some basic setup, but I will explain everything that I am adding. So let's paste in our Unity step. And steps are just a way to define in TeamCity what build steps need to run, or just any steps in general. It can also just be connecting to a REST API, it can be anything really. And in this case, we're just saying it's a type Unity, which will mean that TeamCity will manage anything Unity related for us. But we do need to give it some parameters. I need to set my detection mode to manual in this case. And the reason I'm doing this is purely for this talk. TeamCity does have a built-in way to ultimately deploy Unity to target machines that you want to your target runners. But I don't want to do that because for this talk, I will use this as an example. And so we have to also specify our Unity root path, which you can see right now is only for Windows. I'm also telling it what method needs to rerun, which is the build Windows method to actually compile the game, and some other details that are not that important right now. I'm also going to add in some basic TeamCity features. And these are just regular things you would usually almost always add, which is a performance monitor to make sure that you can actually see build performance. And these few replace contents, most people won't need them. The reason I need to add them is because my team really likes to make life difficult for me. And they often use Windows machines with HTTPS Git connections and not SSH. But obviously, I want to use some kind of SSH key to connect our runner to make it more secure, which means I have to run some regex here to replace the Git's HTTPS with an SSH one. But once I figured that I want it, pretty easy, so no worries there. On top of that, I also added a little demonstrative step to replace the build number in Unity with the actual build number of TeamCity itself. So it will take TeamCity's build number for the game build, and you don't have to manually increment this in Unity, which is a lot nicer, of course. Now, to just show you how easy that was, let's just commit it and just say stage 1 and push it and hope that there's no networking related issues. Yep, that's all fine. Though I did already manage to screw up and add one little bracket too much. So we have to commit again. Stage 1 fix. And all programmers here are starting to recognize all these commit messages already, I'm pretty sure. Then if we go check back into TeamCity, there's this nice little version settings tab where you can see what TeamCity is doing. So right now you'll see it is running Kotlin, the DSL, which means it's compiling the Kotlin and turning it into XML or some other kind of language behind the scenes. And I forgot to add something, apparently a name property. Let me just add that real quick. Yeah, that can just be anything. Unicycle pizza time Windows build. Oh, if you're wondering why it's called Unicycle Pizza Time, that is the game I am writing this step for. It's not really important. It's just as a demo because we won't have the time to actually run the pipeline as well. So you just have to believe based on config that it works, because otherwise I think I'd have to take in 2 speaker sessions. Fix again. Yeah, this is already a nice part about the Kotlin. With XML, usually you only notice it once the build is running or anything like that. This will literally just compile the Kotlin as it was normal code, and then you can instantly see what went wrong. So let's just give it a few seconds to recompile this and to get our results, which shouldn't take too long. Voila. And if we now go look at general settings, we will see we have our first build pipeline here, or well, build configuration rather, which is our Windows build. And if we then go into the build steps for Unity, you will see that there is now a Unity build with all the parameters that we defined, which is the build Windows methods. And also down here, we will see the custom Unity location. All right, fair enough, not a bad start. Obviously, it doesn't end there. Let me just go back to the other page, because that's the easiest to see what's going wrong. Okay, but now at least you can see how easy it was to define a build step. Now imagine you're doing all that in XML or YAML and you don't have any syntax highlighting, or at least not much. You don't have autocomplete, whereas here, it just knows about it. It imports everything and it just knows about it. So it's a lot easier to work with. Of course, we're not ending here. So now, as you have undoubtedly already noticed, this would start getting messy fast, which is exactly what we want to avoid. We only have one single build step and a VCS connection, and we're already at, what is it, 64 lines of code. Even if we were to write it all on a lot less lines, it's still going to be not as easy to read. And of course, the goal here is to make everything easy to read and a lot nicer. So let's start cleaning up a bit before we move on to multi-OS support. The first thing I'm going to do is create a new Kotlin file that will house our VCS connection. Because since this is the full power of Kotlin, we can literally just yoink this to another file. Only have to import the classes that we need, which Fleet makes it super easy for us to do. And now we have to do the exact same for our build type, which is going to be our Windows build type. I also recommend writing your files with a lowercase start letter because it will work with a bigger, with an uppercase. But I have had issues with that in the past with unresolvable errors where it can't import something that looks fine in code and everything like that. So just take it from me. Don't try that. For the rest, it'll be mostly the same, except for you can't just type build type here because it's in a different file and we want to build on it later. We have to make it a class. Now, luckily, most basic types, such as build type, are actually classes you can extend and you can add your own logic to it. So we can just make a class Windows build type and make it extend from the JetBrains Kotlin type build type. And then in here, we can just paste all the juicy details we had before. And voila. And we basically don't have to change anything except for importing all things that weren't imported automatically, such as this perfmon and replace contents, and make sure that everything is ready. Okay. And now in the settings, all we have to do now is make the reference to our new files. So we can just say our vcs.game. And I hope if you just type game, it'll do it automatically. Yes. And any build type as well needs to be referenced in this project part. But that's easy to do. We can just say a build type of this Windows build type and then instantiate it like you would any other Kotlin class. And while we're at it, we may as well add something else as well under the Windows build type, something I forgot to add earlier, which is add a trigger so that it actually triggers when we push changes to the Git repository, because we don't really always want to have to manually trigger it. So let's just give this a simple ID of Windows build trigger, and I realize I spelled Windows wrong. That's all fine. We want to enable it, which it is by default, but I always like typing it full out because if you ever then need to look at it, it's easy to see, okay, it's enabled. And I only want to monitor the master branch because we're still pushing on master and not on main on this project. Again, not my decision. Oh, that is the wrong button, I'm pretty sure. Nice. Well, it's a live demo for a reason, of course. Let me just bring back our lead here. There we go. That is my bad. Okay, and let's just all pretend nothing happens. And okay, now that we added our trigger and everything, we can just commit it again, called stage 2, and hope nothing went wrong this time. And then this isn't going to be anything world-changing. If all went to plan, we should have exactly what we had before, just a lot cleaner now. Now, as you might have noticed, you can already divide this into even more files, like you can move the trigger parts and everything to different places. But I'm not going to do that right now. I just want to already show how easy you can make it a lot cleaner without going too advanced. And voila, TeamCity does not complain, so neither do I. And if we now go look at all the build steps, you should see we have exactly the same as before, with the extra step that we now have a trigger as well, which will trigger when changes are pushed to the master branch. There's also a thing set up in our GitLab where if we push to the branch, it will automatically notify TeamCity that there are changes. So we don't have to wait for the automatic 30-second polling or minute polling. I'm not sure what the default is before we get these changes. Okay. So let's go a bit deeper. You see where this is going, right? We made this code like a little bit more reusable now, or at least we are going to make this code a little bit more reusable. And we want to make use this on many operating systems. Now, if we just copy and paste this into a macOS build type and a Linux build type, yeah, we're going to be reusing way too much code. And we don't want to do that, or duplicating, I mean. So let's start with getting ready for a multi-OS project. First of all, let me just make a file called constants. And the reason I'm doing that is to just house some basically enums in it. So I'm just going to make a class operating systems that I can use to house some stuff. And I'll make a companion object so I don't have to always make a new instance of it to access it. We'll give it a constant value of Windows. And then we will do the same for macOS. And we will do the same on for Linux. All right, and now instead of having hard-coded strings, we can use these constants, and that'll make it a lot more readable and a lot less error-prone, which is always nice. Now, the first thing we can do is already start tearing up this class that we just made, our Windows build type, because this will now become a base build type. Because any OS needs to run the Unity build, which means we can turn this into a base and keep all existing functionality and expand upon it. So let's make this a base build type, and then also rename this into a base build type. And hope that nothing breaks due to the refactoring, which I think should be fine. Another thing we have to do is, because we are going to be extending from it, we obviously need to open the class, which in Kotlin basically means that you can extend from it. It's not a final. Otherwise, I believe default is a final. And let's also give it some parameters now, because otherwise it's always going to run our Windows build. And yeah, of course, we don't want that. So we can give this an OS, which will make a string. We'll also add a build method, which will be a string. And we will add a Unity location that will be a string. Just some basic parameters that we can use to make this a little more dynamic. Now, in TeamCity, the ID always has to be unique. So we can just use our OS here to make it unique, like so. And do the same for our name to make it a little more readable. And for the rest, nothing is really going to change much on top there. What we are going to have to change here is our execute method to accept the new parameters. I think what did I name it again? Oh, build methods, my bad. And in this Unity root here, we are just going to add in our actual Unity location. Voila. And having done that, we can now dynamically make more, or at least we can inherit from this class now and make different OS configurations, passing in all the info we need. So let's show how easy that is now by making a Windows build type, just as we did before, except now we are just going to say class Windows build type. And again, passing our, or not again, I'm going to add in a Unity version as well here. And the reason I'm doing that is to demonstrate that we can then from top in passing, for example, the Unity version, if the version is the only thing that can change in the path. And this can also be mapped to a TeamCity parameter, allowing people to run the pipeline from TeamCity with different parameters. Or even you can fully reuse this code actually, as in you can link this Git repo to multiple solutions. And then use a method in TeamCity, which I will show you a little bit later, where you can just define variables specific for that configuration. And then you literally only have to write the code once and reuse it. So let's make this inherit base build type now. And of course, we have to pass in a few parameters. Now, because this is a Windows, we can make this a Windows operating system. And I'm also just going to import our constants file as this, because I don't want to always type the constants dot in front of it. I think it's cleaner if you can just do this. And then also add a build Windows build method, because that's how the static method in the game is called. And then we need the path, which I am just going to copy paste, because otherwise I need to type a very long Windows string, which I will most certainly get wrong, which is going to be the same exactly as you saw before, except the Unity version is now replaced with a variable, so we can easily pass it in from outside. And now to actually use this, we need to update our settings file here. Instead of referencing the base, we need to reference our Windows build type, which it seems to have already done for me. And we need to pass in a Unity version as well. So I'll just define a Unity version. For this project, for example, we were using, I think it was 2022.2 F1. Pass it in, and voila. Now we should have, again, the exact same as before, except it's become even more modular and even cleaner, which I will also show again by pushing it. Let's just call this stage 3. I know I'm being very original with my commit messages right here. And wait for the DSL to run, which should only take a few seconds unless you're actually waiting on it, in which case it feels like it takes a lot longer. Voila, that is now done. And if we now go look at our general settings again, you'll see that, again, we have the exact same Windows build as before with the exact same steps. So I'm not going to show them in detail again. But this is now fully modular. And to prove that, let's add a few more. Let's do a Mac build type .kts and do the exact same as we did for Windows, only for Mac. Again, a Unity version. And yes, this part is a little bit repetitive, but at least it's a lot shorter as having to copy the other entire class. And again, an operating systems. And I forgot to import the constants file again. Import constants.star. Let me just copy that to do it again later. Operating system.macOS. And we have a build Mac methods. And then I will go ahead and just get the Unity version from my sketchpad over here, like this. And now let's do this for one more type as well. Let's make a Linux build type .kts. And again, I'm sure you're getting tired of this by now, but I promise this is the last time. We create a Linux build type with a Unity version of type string, which again inherits from base build type, yada yada. And this time I'm just going to, oh, great. Operating systems dot Linux, build Linux, and finally the path, which will be home, Bite Me Games, etc. All right, now, of course, just as the other ones, we have to make sure we add it into our project here by making a new build type, which will be a Mac build type, .Mac build type, and pass in the Unity version. And then do the exact same for our Linux build type, and again, pass in the Unity version. Voila. And now let's commit this again. And now, as we should be able to see, if everything is correctly, by just typing, what is like 20 lines of code extra, I think not even that, we should see that we now have complete runnable pipelines for our build configurations for Linux, macOS, and Windows. Let's just confirm that before I am lying to you guys. There we go. So see how easy that was? Because we made one reusable base build, basically, which we can add a lot more to, and we will in a bit. We can now easily make Linux, macOS, and Windows builds. Now, you're probably wondering, okay, we have one base build type. Now, how can we still deviate from that config? Say we want to add a few more steps in, for example, Windows. We want to make sure that we have a clean setup to start with, because in TeamCity, you can configure to not clean the checkout directory before it starts, but you might want to remove pre-built files to at least have some cleanup. This too is still easy to do, and we can do that using a little trick. If we go into the base build type, all the way at the bottom, we can define in this class a new companion object. And in this, we can define a base run order. And this will basically be a list containing the names of all the steps of our base build type, which in this case is only Unity build. By doing so, what we can now do inside our Windows build type is we can change the order. So let's add some new steps in our Windows build type. And since we inherit, we have to call this init method to add some steps to it. Let's add some steps and add a step in there, which will be a script. And I will paste it in to save a bit of time. There we go. And this is just a simple pre-cleanup script. What the script will do is only on the Windows instance here, it will run this command here to check if there's already a directory that is named Windows, because we have in our project, the output directory is the name of the OS that we're building. If there is, it will print it. Delete it, I mean, if there's not, it will print that it couldn't find it and it is skipping the pre-delete step. Now, the issue you're going to run into if you do it exactly like this is these steps will always come after the base build type. But since it's a pre-cleanup step, we don't want that. We want it to be before the base build type. So we can modify the steps order by basically taking a new array list that contains the name of this step here, which is Windows pre-runner. And then after that, appending our base run order from the base class. And we also have to say this is an array list of type string, because otherwise it complains a bit. And by doing so, if we just commit this now and push this, I git add stage 5. We should see inside of TeamCity, once it compiles, I'm just going to go to the Windows page already, because it'll be a little bit faster, just reload here. I'm just going to wait a bit for it to compile again. There we go. We should see a pre-cleanup step now that is running before the Unity build. So we can now modify the complete run order, and we can add steps specific to Windows. And I will prove they are specific to Windows by showing you this here. You'll see the otherwise don't have other classes don't have any pre-cleanups. And this way we can both modify the before, after, or even if you want in between by modifying the run order. So you're not limited in any way by using this approach. For a use case example where you could use this, just to give you an idea, a place where we personally use this is to add more steps after the build for our macOS, because Apple, if you build for macOS, Apple requires your app to be signed and notarized by them before submitted to Steam. And this allowed us to add some steps after the fact to go ahead and sign the application with Apple, which is completely automated as well. But that's maybe an idea for a future talk if anyone is interested. Okay, very nice. So we now have a basic multi-OS build structure where we have a Unity build going on. We have some pre-cleanup steps on some parts. It's all completely reusable. It's really easy to read, in my opinion. Correct me if I'm wrong, of course. I did say we were going to add some tests, didn't I? So let's do just that. To add some tests here, we do have to make a few changes. I want these tests to be able to run on any base build type, because we might want to run them on Windows, we might want to run them on macOS. It doesn't matter, it shouldn't matter. And to do that, I will just add a new variable called isTestRun, which is going to be a Boolean. And doing so, we can now also go a bit lower into our build steps, and we can add a little if around here, in which we can say if this is not a test run. Because we have the full power of Kotlin here, we can literally add if statements in our compile logic. And if this is not a test run, then we want to run this Unity build. Else, if it is a test run, then we want to make some changes. We want to basically do mostly the same as before, except there are a few key changes for when you run a test in Rider. For example, we want a different name. We want to have a Unity, let's just say we start with edit mode tests, Unity edit mode tests. The ID is going to be a Unity edit mode test runner. And I'm pretty sure you're already seeing where this is going, but I will just paste in a few of the other things so we don't have to always just type that again from scratch. Like this. The only last two things I will type in, because those are new, is that we need a test platform defined. And this is so that TeamCity knows which kind of tests it needs to run. For those that are not familiar with Unity, in Unity you can have both edit mode tests and play mode tests. Edit mode, you can basically compare with unit tests, whereas play mode tests are more integration tests. They will basically be able to start up the whole game and actually run as if someone was playing the game. So this allows you to validate some game logic that is otherwise not able to be validated. And our test platform in this case will be edit mode tests. And then we also need one more parameter, which will tell TeamCity to actually run the tests. So we set this to true. Voila. And doing this now, if we now specify that this is in fact a test run, it will actually run our Unity tests instead of doing the actual build. But there are a few things we need to change now, because if we were to define this type now once, if we, for example, say that Windows is both build and test, then we have an issue because the ID has to be unique. So what we can do here is we can just add like a little bit of an extension here, where we say if this is a test run, then I just want to say underscore test added to the ID, and else we don't add anything before the build. And we can do the exact same in the name here. Voila. And of course, we can't forget down below about our little companion object, because if we don't add it here, then again, these steps would run after the other one, or before the other one, which we don't want. And it's all totally fine, by the way, to define steps here that don't actually exist. TeamCity will not complain. So feel free to define all your steps, even the ones that are beyond conditionals. There's no need to say if this, then that step, if this, then that step. So we can just say that there is a Unity edit mode. What is it again? Unity edit mode test runner, I think I called it. Let me double check. Voila. And that should be that. However, you might have already noticed now, yeah, of course, we don't want to copy paste this again for even more possible test types. Let's use a little bit more of the Kotlin language features. So what we can do here is we can define an array list containing both test cases. So we have edit mode and we have play mode. And doing this, we can actually use the map operation to basically just return us a list of steps, which TeamCity will no issue be able to interpret. And then we can just do things like this. We have our it tests. And for those that don't know Kotlin very well, it basically just refers to the variable passed into this map. You could also just define a variable here, but it's always referred to that. And doing that, we can also replace this part by saying it's dot uppercase test runner. We can change our test platform to it. It doesn't matter if it's upper or lowercase, by the way, for the test platform. TeamCity doesn't care. TeamCity just accepts. It's not picky at all in some areas. And voila, that should be that. Now we do have to modify our inheriting classes because we did add a new variable. However, I will make it a little bit easier and declare this variable as default false, as in we default do not want to run these tests. However, for Windows, I do want to have the option to actually run these tests. So I will just add a little variable to Windows specifically, which is going to be our isTestRun variable, which is again a Boolean, and pass it into our base here. Doing this now, we can reuse almost all existing logic like this. And all we have to do now, instead of just passing in Unity version, is we also have to pass in if this is a test run or not, which will be false. However, should we now want to add Windows tests as well, we can just say this is now true. And that is all we have to do now to add tests. If we now ever want to do the same for macOS or for Linux, all we do is pass a variable to true, and it just works. You only have to duplicate this line, or not even duplicate it if you don't want that. So doing this, we can now just commit it again. Hope that we didn't forget anything. Everything's been going too smoothly, so I'm expecting something to break here. Give it a couple seconds again, and then we should see that we now have a new build type, which is going to be specifically our tests. And I did forget something apparently. Let me just double check what that is. Mandatory type. What did I forget? Oh, right. I forgot to add in all the other variables for the test here. Let me just add it in. I think I accidentally deleted that because otherwise it doesn't know that it's a Unity type, and then it won't know what step it is. That's logical. Let's hope I didn't forget anything this time. Otherwise, I have to quickly check something. But I'm pretty sure everything's here. The name is here, the ID is here, the type is here. Yes, let's hope that is all, and that is an easy fix. That's, of course, a risk when we're running these live demos, but I do always like coding live a lot more than going through pre-written codes. There we go. And now if we go look at our settings, we see we also have this Windows build type. This is all fine and all. We have a nice little Windows build type now, but doesn't really do much. Like, it runs the builds, sure, because it has this trigger, but it doesn't stop any of our other builds. We normally, at least in the normal world, want to stop our other builds if the tests fail. So if we run Linux, macOS, or Windows, then we want to first run the tests. And if that doesn't work, then yeah, of course, we don't want to go along with the rest of the pipeline. You could make a case that you first want to do the build, of course, but that's already included in the test, so it doesn't really matter. So to do that, we need to now add some dependencies. So for those that haven't worked with TeamCity before, in TeamCity, you have two different forms of dependencies. You can define snapshot dependencies, and you can define artifact dependencies. Basically, the snapshot is basically saying that you want to depend on another pipeline having succeeded and all that, or the status of it. Whereas in artifacts, you can define what files you want to take over from another pipeline. Say that one pipeline builds your game, and you have an artifact dependency on that pipeline from another one that deploys it to Steam, for example. Totally not kind of telling what we're doing in our own game, but to do that, we want to modify the base class again, because we want to basically say that we can always depend on a different pipeline, and we want to, again, do it in a dynamic way, which is the goal of this talk, if you remember. So we can do this, again, by adding a dependencies. Yep, my English is not great. Which is going to depend on a dependencies array, which I have not yet created. And I'm going to add it before this is test run, because this is a default value, of course. And let's say that we have an array list of type build type. The dependencies basically always require the build type that it is depending on. So we can now say that we have a dependencies array. I seem to have fallen back into .NET coding instead of Kotlin, in which the variable is behind the parameter. And here as well, we can do the exact same as we did before with the map operator, showing you how easy it is. We can call the dependency function where we can pass in our it again. And in there, we can now say that we have a snapshot dependency. And we want to add a little thing here as well, because if there is a test, then I want to make sure that if it's a test run, then I always want to make sure that it runs the latest tests. I don't want it to say, okay, previous test run has succeeded. It's the same inversion. No, I always want to rerun the tests, because tests are important, as any ITer would hopefully say. So what we can do is we can say if the name contains test, and I want to do it case insensitive, so I'm setting this to true, then I want to say that I don't want to reuse builds. reuse builds, no. And by doing so, it will force TeamCity to rerun a build for every time the test is called, the test dependency is called, instead of reusing an existing one. And if that fails, then I want to mark it as fail to start so that it doesn't continue. Now we want to do this again, but then for the artifacts dependency, which is going to be a lot simpler, because here we just have to say artifacts, and we pass in it again, and then I just have to say how the artifact dependency works. What is going on here? Or sorry, you don't have to pass in it. We already did that above. My bad. Artifact rules, and I just have to say that we basically want to take in anything. Purely for example, you can be very selective here, but I just want to take in anything here. And the keen eyed among you might have already noticed that we could actually just merge these both because they're kind of the same thing. We could theoretically do something like this, and that will work just fine. But there's a reason I'm separating them, and that is because you want to be a little bit more dynamic in what you want an artifact dependency on and what you want a snapshot dependency on. Even though I know that I'm passing them in the same array here for demonstrative purposes, but in the real world, you might want to have the option to expand a bit upon that. But just for the sake of this talk, I'm passing them in as one little variable. Oh, I also forgot something down here now that I just noticed. We can also do the exact same as we did on top here, down below, which would make it a little bit more nicer. So we can say that we want our, and I realized that I just overwrote my copy again. We want our edit modes and our play modes. And we want to map that to this. Fine. Again, just to add it in this base order so that we don't have the special case where some steps are not run when you expect them to run in different orders. Okay, but now back to the dependencies. Now we do want this one to be passed through all the classes. So to do that, I will just copy this here and paste it into all the classes, like this Windows build type. We want it to be run before the is test run, and import the class. Again, the build type, passing the dependencies to below. Voila, and voila. Same for the Mac build type down here. Dependencies, and the Linux build type dependencies. And now when we go back to our main settings file, you will see that a lot of things are complaining because it's asking for some dependencies, which we don't have. So let's add those. First of all, one of these dependencies is going to be the test build type. And these, yeah, as you know, this Kotlin is just returning a new instance of this class. So we can also just store it in variables, as you would expect. And here we're just going to say there is no actual dependency passed in. And I need to put it behind there, my bad. But this will be our test run. And we also need to add this one to our build types, because even if doesn't matter if it's dependency or anything on it, you always need to add it as a build type in the main file. And now we can also create our Windows build type, which we can say that we have a Windows build type. Actually, no, we don't need to do it. We can directly put it in this build type. So we can say a Windows build type, which will not do the test run, but it will add in an array list of, and I will just do that here already. We can just say our all tests. It's going to be an array list of the tests build type. And we also have to say that is of the base class build type, because otherwise it will try and make it too specific and you can't pass it along. Now we can just say tests, and these will have false. And for these two, we just need to pass in the tests and the tests dependencies. And now if we hopefully for the final time compile, stage 7, I lost count, but I think it should be fine. then we should see if the demo gods want to bless us one more time while we wait for this Kotlin DSL to run. It's always the exciting part, waiting for the DSL to run. Always hoping nothing goes wrong. Usually something does go wrong. Unless when you're giving a talk, I shouldn't have said anything. Array list cannot be cast to... Wait, where is it complaining? Let me just double check. Uh-oh. Because where is it? Off the map. Obviously, this has to happen on like the last possible step. Oh. Oh, yeah. I'm pretty sure in Kotlin you can just do this. Yeah. Thank you. Thank you very much. Can I say I was testing you or? No, I'll give you the credit for that one. This one time. Let's hope this works now. Running the DSL. And there we go. Now it actually does compile. Great. So now what we should see is that all our build types now have a dependency for both the snapshots and the artifact on this Windows build type. So that means that whenever you run any of the other builds, it will actually run the other build as a Windows build and make sure that the tests are working before it runs all the other builds. And the last thing I want to touch upon is a way you can reuse all this code even more if you are so inclined to do. In TeamCity, in the version settings, you have an option at the top called context parameters. This gives you the option to link one single settings repo, like we just wrote, to many different build configurations, with the option to then replace some variables in there with variables you specify in here. So in theory, if you wrote it modular enough, you could write one singular build configuration like this and reuse it in all your games if you stick to a same kind of structure in the game. And yeah, with that, we have a fully functioning OS multi-OS pipeline that will do our Unity builds, that is reusable, that runs the tests, that is easy to read, very, very modular. And yeah, with this context parameter, you can even just write it once and reuse it, which I already explained. And I hope for the people that did not know anything about TeamCity before, was at least a little bit somewhat easy to follow. I tried being as clear as possible with the time constraint given to me. So yeah, with that, I thank you all for listening.